Welcome to Swell Academy, Mr. Math here. Today we'll be working with solving for variables. I got a cool piece of paper here. Actually, it looks like a crumpled piece of paper, but it's pretty smooth. So I figured we'd just have a little fun, use some crumpled paper that isn't crumpled. So basically we're given this question solving for variables, and what we have is a poop emoji multiplying to a smiley face, subtracting some love, equaling some cherries. And here we don't have any numbers whatsoever. And what we're going to be asked is to solve for maybe one of these pieces here. And what's going to end up happening, so we're going to solve for the poop emoji here. And basically what we're going to want to do is isolate this, get this by itself by doing some of your, normal, regular algebra moves. So if I want to get this by itself, first thing I want to do is take the subtracting heart and we want to add the heart. And the reason I'm using some emojis is to show you that even if you're not given numbers or letters, you could still solve for something. It could be numbers, letters, shapes, it doesn't matter. And so we're adding the heart to both sides, and we end up with some poop times some happiness equal to cherries plus some love, right? And if I want to get this by itself and I know it's multiplying, well, I'm going to divide both sides by some happiness. And what you get as a result with your emoji by itself is you get poop equals a couple of cherries plus some love divided by some happiness, and you'll get some poop. Now, it makes 0 sense, but we're just demonstrating this here to show that I was able to solve for an emoji, okay, without any letters or any numbers. No letters, no X, Y, Z, or 2, 3. There aren't any numbers here, and I'm able to solve for a variable. Remember, we use letters for variables because it's very connected to numbers and it seems to make sense. But I can put any variable, 2 star is equal to 10, and solve for that variable and say star is equal to 5, right? I could say if a star represents 5 units of something, the star represents 5 stars or whatever, or the symbol of star represents 5 stars, then 2 times those stars will give me 10. And that's the idea here. So when you're given a problem where there are just numbers and letters, let's say, and you're given a common question, 2x plus 2y is equal to w. So here we're back to numbers and letters, and we're asked to solve for, let's say, x. Okay, usually they'll give you a semicolon, or they'll say solve for x. And that whole idea, we just demonstrated that, okay, we're trying to get this x by itself. And it's okay. Usually we're used to solving for a letter and getting that letter to equal a number, right? But we just showed that we had a picture equal to, or emoji equal to other emojis. So solving for a letter could just mean getting that letter by itself to show what that letter is in respect to everything else. And in order to do that, we would subtract 2y from both sides. Make sure you're rewriting your equations when doing this and keeping all pieces and signs in order here. And then we want to get x by itself, so we divide by 2, and we get this result where x is equal to w minus 2y over 2. And we've solved for the variable. Yeah, it's not equal to a number, but it is equal to a quantity of something. It's equal to certain pieces that are dividing and subtracting. And this is how we solve for a variable. Basically getting it by itself and then having it equal to the pieces that we moved while isolating it. Another good question I like that deals with some fractions and distribution is this question where they give you b is equal to, and here we go, enter in fraction, a plus 12. Okay, and they want us to get, I'll just semicolon, and we want to guess a by itself. So if they give you semicolon a, they want you to solve for a. They may just say, again, solve for a. So let's do that. First thing I want to do is get rid of this fraction by multiplying both sides by 6. End up with 6b is equal to 5a plus 12. Now there are two ways to solve and work this problem, and I'll show both ways. But first way I want to show is actually using the distribution to try to get a by itself. Yeah, you can divide by 5, and I'll show you how to do that. But this is an easy way not to make mistakes. So we have 6b equals 5a plus 12. Oh, I'm sorry, this should be actually 5 times 12 is 60. And then subtract the 60 from both sides. And you get 6b minus 60 is equal to 5a. And we're solving for a, so we're getting a by itself. Divide both sides by 5. And I end up with a is equal to 6b minus 60 over 5. And this is what a is equal to, and that's what you get when you solve for b. You can take this 6b equals 5a plus 12, and you can go the route of dividing by 5 and ending up with, and then subtracting the 12 and basically having 6b over 5 minus 12 is equal to a. But I believe this is a more solid answer. Both are correct. Both of these are correct. And then you could end up, finding like denominator here, but I think this is the best way here to work with this. Another good question that we could look at is one where you have, and I just wanted to throw that in there, one where you had it a square. I think it's always good to just throw something squared there. And in one, we're going to solve for the a. So in this one, we'll solve for the a. And then in another, we're just going to simply solve for the b here. Just so I'm going to show you both, kind of how to get rid of the square root here, and then here how to just kind of keep the square root as is. So if we're solving for a here, we're going to subtract both sides by b. Now remember, c minus b aren't like terms, so they have to be left as 4, or left kind of c minus b. Divide both sides by 4. C minus b over 4 is equal to a squared. And this is why I wanted to show you, in order to get rid of a square, you have to take the square root. So we'll do that to both sides here, and we'll get a is equal to, and it's important to put plus or minus, because remember that negative 4 squared is equal to 16, and 4 squared is equal to 16. So you have two answers squared, one negative, one positive. So that's why we put plus minus here, is equal to plus minus square root c minus b over 4. Now another easier one, but I just wanted to show you in case you encounter it, is where you're solving for b here, and you could just simply take this whole piece and subtract it from both sides and end up with c minus 4a squared is equal to b, and here we have what b is equal to. So I wanted to demonstrate, basically, if you're solving for a variable that's kind of, it's not being multiplied or divided or squared by anything, then you could take this whole term here, the 4a squared, and move it to the other side by subtracting it, and this would be your final answer. Remember, if you want success, you got to add some failure. They go hand in hand. And you do that through hard work and making math easy. Thanks for stopping by.